So we'll begin with our executive and director of the John Theurer Cancer Center, Dr. Andre Gua. He is an internationally renowned clinician and researcher. Since joining John Theurer Cancer Center, Dr. Gua has spearheaded the development of its tissue bank and led New Jersey's largest program for lymphoma. So please, let's welcome Dr. Andre Gua.
Thank you, Mary. Good morning, everyone.
Good morning.
Isn't it great to be here?
Yes.
I love the title, What's Next? I mean, I can tell you all my friends always think that I'm too short on the phone. I have no patience. I hang up quickly. But when I pick up the phone and say, what's up, what's next? Always. So they say, Andre, there's nothing new. I talked to you a few hours ago. So I love to be driven with the future, directed with the future. And I think it's a very exciting, perfect title because what's happening in oncology is amazing. This is the best time ever to be in oncology. And actually, not only I mean it, it wakes me up at night. What's happening in oncology, and I'll go into more detail in a minute, is totally amazing. And I'm so happy that you're part of this. And pushing forward are very innovative and progressive in trying to push new ideas and concepts in to cover our entire population when we treat patients with cancer. The other reason that makes me very happy to see this is that when I was very involved in designing and building the building with my colleagues on our team, I met with the architect the first time. I said, I don't want this to look like a high school. I want this to look like a place of life. That patients want to come and their family the days they don't have to come. Here we go. You're coming the days you don't have to come. And you didn't even know the food would be good. So that's really exciting. And then finally, the reason why this is an amazing thing is that when you see Tara Crowley, that was my patient and sort of was struggling, trying to put her life back together. And then, moving along, eventually got involved into Stupid Cancer and was such a force behind this to try to, develop the first workshop here. And I think it's a great success. So I just want to give her a round of applause. Where's Tara? Where's Tara? Remember in the clinic? Yes. Remember when we insisted? That was great. I mean, that's really wonderful that you did that. So I think it's, before we move into why this is so exciting to be in oncology these days, obviously I have to acknowledge a number of people involved, and I want to acknowledge obviously Anita, Tara and her team, and the New Jersey Stupid Cancer Coalition, with again Anita, Tara, and Gina Londino from Leukemia Lymphoma Society involved as well, Debbie Vincent from Gilda's Club, and Brooke Lasser from Valley Hospital. It's great that we all work together. I also want to thank our sponsors, the Hackensack University Medical Center and the Foundation, and also the Leukemia Lymphoma Society. I also should acknowledge our speakers with Matt Zachary, who is the founder and genius behind this whole effort. And it's really amazing that not only I was lucky to have dinner, it was very entertaining with him a few weeks ago. I mean, the drive behind this guy is what it is all about, right? So I think it's exciting. And then we have additional speakers. We have Julie Larson, a young adult psychotherapist, Robin McConnell, who drives our nutritional effort, and the cooking demo classes with a great enthusiasm every Friday. And finally, we have our JTCC DJ, Oscar Lerner. And finally, support from Stacy Weathers from the Leukemia Lymphoma Society, and the leadership at the Joe Sanzari Tomorrow Children Institute, and then with Maureen Koenig and Jeffrey Boskamp and their team. And I think that's very exciting that we all together, regardless of the institution, all that we should work all together so that we provide our patients with the best outcome. It is so amazing, again, the driving force in oncology, and then that's where I think the core of the few minutes that I'm going to talk this morning is about that where we are coming from in cancer, where we are, and where we're going, and that's really cool. So talking about where we started in chemotherapy, does anyone have any idea where chemotherapy started? Very good, very good. So you have one more cupcake. So in 1942, December, there was a ship, a Navy ship in Bari, Italy, that was bombarded by the Germans. Because Bari, although it was sort of South Italy, was a very sort of a hub for the Allies. So the Germans went, bombarded, and all the soldiers became very sick. Some of them died. but became very sick. So the authorities at the time sent 2 physicians, and one physician was called Stuart Francis Alexander from Hackensack, was sent to try to understand why these guys were sick, losing their blood counts, vomiting, being sick, and some of them died. They died from chemical burning and this, but also mostly from toxicity on their blood count, infection, and GI tract. So they realized, put 2 and 2 together, that this was toxic on cells of the bone marrow. Maybe we could use it in bone marrow disease, leukemias and lymphomas. So they went back and declassified nitrogen mustard because it was potentially not just a bad poison gas that had been banned in 1925 by the Geneva Agreement, that they would not use that anymore. And secretly, they had shipped all these containers of nitrogen mustard. And it's ironic that this thing that was so toxic for our soldiers became the savior of millions. So this was the launching of modern chemotherapy. Because 2 pharmacologists at Yale were interested in the lab, and then based on the effort of Alexander from Hackensack, who was a cardiologist and internist, the head of the Internal Society of the Medicine Society of New Jersey at the time, they went back to the lab and starting on mice, and that became the treatment of lymphoma. Lymphoma, not because I'm a lymphomaniac, but lymphoma was a drive. And the first patient was treated, and then we started to treat patients. Some had the ideas at the NCI, like, why not treat cancer like we treat TB, by combining different drugs? So that became the MOP regimen, MOPP. M for miclorhitamine, which is nitrogen mustard, became the launching of modern oncology, first treatment, because before, Hodgkin disease was treated just with radiation. And the first patient, obviously, was a patient who had a lymphosarcoma, because this was the diagnosis at the time, had failed radiation, so was given nitrogen mustard and responded very well. So MOP was so toxic that it was abandoned because it would give not only sterility, almost 100%, but it would give secondary cancers and tumors and leukemias. So then we went to ABVD, and ABVD became sort of the standard. Now we are trying to do better in ABVD and less than ABVD in some patients who have really good prognosis Hodgkin disease, because patients do so well that we don't want to have them long-term side effects. Isn't it amazing that we went in a relatively short time from, we have no treatment, then we have chemotherapy, and now we're trying to do less chemotherapy because they do so well. Well, that's sort of fasting forward, because in between there's been decades of trying to make progress with a lot of chemotherapy agents that were all cytotoxic. So cytotoxic are drugs that mostly kill the cells when they divide. Classic chemotherapy. Then, moving forward, we had progressively a better understanding of cancer cell biology. With human genome sequencing, with the technology that we have, we can start to look deeper in cancer cell biology. And then that offered an opportunity to go beyond just killing the DNA, cutting the DNA when the cells try to divide. And that became what we call the targeted biological agents. So we have now more than 1,000 drugs in the pipeline of oncology. 1,000 drugs in the pipeline of oncology. So that's a challenge, but at the same time, I think we have a solution. Because when we look at cancer, there's something that is totally amazing, and thanks God we're not all clones yet, right? When we look at cancer, cancer is a very diverse disease. There was a very important seminal paper a few years back, which was a tremendous effort, sequencing 120,000 hotspots of DNA that could be hotspot mutation for cancer. Those are mutations that are frequently involved in cancer. So the idea was to try to see, we're going to look at what are the important drivers, because if we can select the important drivers, we have a better treatment. Out of 11 breast cancer and 11 colon cancer, 2 tumors for which there's one main type, basically, these 11 colon cancer and 11 breast cancer look the same at the microscope for breast or colon cancer. But when you sequence 130,000 hotspots, the result was that you need about 80 to 90 mutations to make the cells abnormal enough to become a cancer cell. And if you don't understand, you stop me, okay? Because I speak slow. So the result was that you need about 80 to 90 mutations to drive the cancer cell, but between the colon cancer, or within the group of colon cancer, or within the group of breast cancer, there was very little overlap. What did it tell you? Well, there's actually 10–15% of overlap. So that means the cancer cells look the same under the microscope, but they're very different because the accumulation of mistakes. Cancer is nothing else than an accumulation of mistakes that drive the cells crazy. It's not contagious, it's not a big deal, it's just an accumulation of mistakes. What's amazing is that, again, when you looked at the colon cancer or the breast cancer, there was only 10–15% of overlap. So that means these patients had different mutations. Why this is important? Well, when you talk, remember I said we are using now a better understanding of cancer cell biology to try to pinpoint the important target that could kill the cancer cells. So you need to make sure that you know you have the right target. So we have to stop to do the clinical trial the way we do it. We have to do clinical trials that are quote-unquote molecularly relevant. So that means we need to make sure that we have the right target that is driving the cancer cell so that we can use the right drug. And that's what really wakes me up at night, is that we have to move towards precision medicine. Precision medicine is that when patients will come, we will be able to actually identify what are the key factors in their tumor cells to try to customize and tailor the treatment. That's what's called precision medicine. So that's something that we have gone a long way. So remember, a large number of novel therapies, a better understanding of cancer cell biology and diversity, so we have to put this together and try to do trials by looking at the molecular ID card of the tumors. That's a really important thing. The third aspect that is very important in oncology is that we have better ways to manipulate the immune system. So in lymphoma and leukemias, for example, but also in some other tumors, we are now able to harness the immune system very well. And one of the best treatments, everyone would like to have a vaccine against cancer, obviously. This is very complicated because tumors are so different, and then the tumors have the ability to stop the immune system from reacting against the tumor cell, to escape the immune system. So we have to break this tolerance. So we have amazing drugs now that are blocking this tolerance to try to enable the immune system to fight against those tumor cells. And ASCO this year, coming in a few weeks, will be full of amazing data in solid tumors for not the first time, but to confirm the impression from last year that using antibodies such as PD-1 in lung cancer, for example, which is no one would have really thought of a lung vaccine in lung cancer, gives amazing results. But back to my story of lymphomas and leukemias, not because I'm a lymphomaniac, but because it's a great model. We do what's called allogenic transplant. So we take the cells of someone else and we inject them in the body of a patient and we change their immune system. And the rubbing of the two immune systems slowly allows the new cells to take over and fight against the recurrence of the lymphoma. And that's the best cell therapy, that's the best vaccine, because you don't necessarily know and don't necessarily need to know, really, frankly, what the cells are fighting against for, as long as they do it. So we are doing a lot, thank you. We are doing a lot of these transplants here. For the first 6 weeks of this year, we actually had already 80 transplants performed at Hackensack. So that's quite amazing, and half of them being allo transplant. We do now allo transplant in patients who are in their 70s because we have ways to do what's called a mini transplant. The full-blown allo transplant, when you use total body radiation, very heavy chemotherapy to wipe up the bone marrow before you inject those new cells, is very toxic because patients have a lot of graft-versus-host disease, which is basically an autoimmune disease, very acute autoimmune disease from the graft that is fighting against the host. And that's very difficult to manage. So now we do these mini transplants, and patients do really well. So we can do that in patients who are getting older. But that brings to the last thing that is very important, is that can we harness and do cell therapy? And I'm sure you heard on the news what's called a CAR T cell, chimeric antigenic receptor T cells. So the T cells are the fighters of the immune system, so the coordinators of the immune system. And we can modify those cells so that they can recognize lymphoma cells or leukemia cells. And we have patients, I mean, this was first done at UPenn, but now this is done in several centers. We have 2 patients recently that had a refractory large cell lymphoma that would not respond to any chemotherapy, that there was no option, who both went into complete remission after injecting some cells that were modified of their T cells. And that needs to wake you up at night. So I think it's extraordinary what's happening in oncology. The number of opportunities that we have together is unheard of. That's why I started this talk by saying this is the best time ever to be in oncology. So when I'm around in the ICU, I always ask the residents, what do you want to do in life? And they look at me and say, I'm going to be a doctor. Of course, that's why you're here, after all. But what do you want to do? I say, you have to be to oncology, because it's going to be the first real personalized medicine. This is going to be the most exciting medicine in the next couple of decades. So it's great that we're part of it. In spite of this great landscape, great opportunities, we still have some challenges, obviously. Our population is getting older. For example, lymphoma in patients who are, not patients, in people who are more than 80 years old, the incidence of lymphoma has increased 500% in 10 years, 500%. And these patients are in good condition, so we treat them versus some people think, you know, they're getting older and all that, should we treat them? So when I was at MD Anderson, I had a patient that came to see me, 95 years old. And then she had relapsed lymphoma and no one wanted to treat her. She was this little, you know, Houstonian lady driving a big Cadillac with a big hair and very skinny and smoking. And then I said, why not? I mean, we have rituximab and some chemo, we can give her some chemo. She came to celebrate her 99th birthday and I bought her a cake in a clinic. I think that's the way it should be. So the challenges are, and particularly for young adults, it's wonderful to have this initiative here, and again, thanks, Matt, for doing this, and your team, is the fact that young adults are often, you know, in between two chairs. They're not just alone to not want to go to necessarily just purely pediatrics environment, or adult, because cancer is perceived to be a disease of older folks. It's actually not true. And one of the issues is because they're not exactly included in what's called a classic adult or the pediatrics, often their disease are not necessarily part of the clinical trials. And I cannot tell you how many times when I was at MD Anderson, we had protocols that, you know, the age limit still these days. The age limit for a protocol for innovative therapies, you have to be more than 18 years old. Somewhat arbitrary, this has been put and carried along, and that makes this population not necessarily able to have access to early drugs, early development. And that's really important that we emphasize that we think of the whole population, because they might have, I don't think this is necessarily well established. There is data that suggest that some of the tumors, some different tumors, a little bit, but also some of the tumors in the young adult have a different biology. I am not a firm believer of that. There might be some different genetic susceptibility, for sure. But if you take the example of acute lymphocytic leukemia, which in a pediatric protocol, patients do extremely well. In adult protocol, patients do relatively poorly. I mean, with a significant difference. And so when you treat young adults with aggressive regimen because they can't tolerate chemotherapy, heavy chemotherapy, they do really well. But if you treat them with an adult protocol, this might not be intensive enough for their disease. So I think we need to, thinking that just because there's an age, there's clearly a different biology, might not be necessarily that something that holds over time. So I think it's important that we are cognizant that we need to work together to offer the same opportunities for every patient, to include and offer novel therapies, to include patients on clinical trial across the board. And it is notorious that young adults are not necessarily included again in clinical trials and potentially slowing the progress into the outcome of their disease. Do you guys know what's the percentage of patients on clinical trials in the US? Give me a guess. 30%. 30%. Between 3 and 5%? 3 and 5%, and unfortunately across the board, and that's a real big problem because when you want to try to develop therapies, and I understand clinical trials have sometimes a connotation of being, oh gee, I'm going to be a guinea pig, or gee, because that's the end of the rope. This is not true. First of all, this is not true. There's clearly data that show that patients on clinical trial do usually very well because they're monitored very carefully, but also there's so many novel options now. The clinical trials, the era of doing placebo or randomized trial, or classic randomized trial, you guys know what the randomized trials are, right? So you need to raise your hand, otherwise I'm just going to put a video next time. So the randomized trial, the way we develop clinical trials is easy. We do phase 1 studies. Phase 1 is to look at, if not efficacy, to look at how a patient tolerates chemotherapy. So we do research in the lab and try to identify new drugs, new targets, right? So when there's a hint, we test animals, and then we go into the clinic and do what's called a first-in-human experience. We have a phase 1 unit here that does first-in-human experience, led by Dr. Gutierrez, Martin Gutierrez, came from the NCI. These first-in-human trials are very important because you go very slowly. You enroll 3 patients at once to make sure there's no major toxicity. And once you find a dose that seems to be reasonable, then you increase the number of patients and try to see a hint where this trial is going to be helpful. This drug is going to be helpful. That's the phase 1 trial. And then once you have identified a bit of a niche, you go into the phase 2. Phase 2 is that you're going to say, you did in the phase 1 in a variety of different tumors, you identify that, for example, a patient with Hodgkin lymphoma seemed to respond better, or myeloma, for example, than the others. So then you're going to do a phase 2 in myeloma or Hodgkin lymphoma. That means you take the appropriate dose that you define and test it in that population to confirm if there is an efficacy. Then that's where the problem is, because then we have to go into what's called the FDA approval process. So we have to do what's called a randomized trial or a phase 3 trial. So phase 1, 2, 3. Remember, I'll quiz you in a minute, right? You don't get lunch if you fail. So the phase 3 is that when you take what was the old standard of care for this patient population, and then now you compare with a new treatment or a new combination. And you have to enroll a very large number of patients. And it's not always easy to tell someone that you're going to decide on a computer. And obviously this is done on a computer because otherwise there will be even subconscious bias on physician making decisions. So that's the classic phase 3 trial, and you need to show what's called a clinical benefit from the FDA standpoint for a patient to move into the next trial. Well, what's great now, remember I said there's so many new opportunities, so many new drugs, and a better understanding of cell biology, so we need to marry them both, otherwise we cannot do the trial the way we do it, because there's too many drugs to test, and the patients are so different from one to the other that you're going to lose your patient population in these large trials. So we have to do trials that have a real rationale. And we are starting an effort here with Foundation Medicine, company launched out of MIT in Boston, to define molecular signatures of patients to try to help you guide what kind of treatment you're going to use. And that's really the core where oncology is going. To be able to decide we should use X, Y, and Z. Because if you have the appropriate target and the drug works, it's going to work or not work if the drug is useful or not, but you'll see it very quickly because you're going to take a little bit more apples and apples instead of apples and oranges and pears. So you have a small number of patients, and the FDA already agreed that they would approve clinical trials based on a small number of patients if you have the right target, that you show you hit the target, and then that you show that you have a high response rate. So then you're going to have a signature defined by this molecular testing, and you're going to have a high response rate. So you're going to be able to test the patient that should get X, Y, and Z. So then you could approve a trial based on 50 to 60 patients. And that would speed up enormously, hopefully, that's what we are hoping for, that will streamline the drug development process and speed up the process, and potentially by reducing the length that required to develop a drug and to make it accessible to the patients would hopefully reduce the cost. And that's really important as well. So you see there's a lot of things that are going on in oncology, and I'm not going to go into the novel technology, nanoparticle, molecular imaging, that will also help us do these trials better, cleaner, better, with a rationale that we can decide what kind of drug we should pick. It is important, and I want you to be cognizant of the fact that when someone talks about trials, it's really important that there are very often these days what's called optional biomarkers trial associated with it. I'll explain to you in a minute what it is. So in order to be able to identify if you hit the target, or if you have the right target, you need to get a piece of tissue. You need to get cells, right? So often these trials are still considered a parallel study and optional. And I think it's very important to encourage every one of you to carry the message that giving tissue of the tumors is very critical, because once you have the tissue, you can build up a tumor bank and you can actually look at enough samples that cover all the different types of tumors so that you can analyze them and be able to make progress in classifying the treatment. So the classification of cancer now these days is based on what? Where the cancer is from, so the organ. So it's a stomach cancer, it's a colon cancer, it's whatever, breast. The future classification of cancer will be different. It will be based on the driver of the cells. So there will be, we already see that, for example, in some of the drugs in lymphoma and renal cancer. Some of the drugs work well in both diseases because they hit a target or a pathway that is very important in those tumor cells that is shared by renal cell cancer and lymphoma. So we're going to modify the classification of cancer from organ-based classification to more a molecular classification of cancer. So once we have all this, we're going to make that's why I said it's so exciting to be in oncology, because we have so much information, so many new ways to do our clinical trials that we're going to make a lot of progress. We already have made a lot of progress. The survival of across the board in cancers has dramatically improved since the 70s to now. It was less than 50%, now it's close to 70% across the board. Some cancers have reduced in incidence because there's lifestyle changes. And I think it's really important that you are part of this. It's important that we do work together. I always tell my patients when I meet them the first time that this is a teamwork. You know, I'm here because I have the expertise, the technology, access, and all that, but we have to work together. So the more you understand, the better it is. Because when you don't understand, it's more anxiety generating. So don't be afraid to ask questions here or to your doctor. It's a team. We work together. The patient, the caregiver, the social media, the stupid cancer, everyone around is really important that we work as a team. And one final spot that I want to hit today is that many of you are doing well. Some of you are still in treatment. It's important that you stay on the boat once you're done. And once you've done so well, it's important that you participate and get involved in cancer. It's very important that you participate and help others who are just joining the crew or jumping on the boat. And I wanted for that reason to get Mark. Where's Mark? I want you, Mark, to say a few words. Mark, you want to come here and say a few words? Mark is one of my patients who went through a little bit of a difficult time, but it looks like nothing ever happened. So he's going to share with us his experience.
Good morning, everybody. Wasn't exactly planning on speaking here today, but
I'm sorry, do you mind going to by the microphone?
Is it on?
Yeah.
Yeah, okay.
There we go.
I would first like to thank Dr. Gua. If it wasn't for him, I wouldn't be here today. Him and his team, I can't say enough for him. I am actually 2 years post-transplant. I had a stem cell transplant March 7th of 2011. My journey started with non-Hodgkin's lymphoma. I was cured with the lymphoma for them to tell me 3 months later that I was diagnosed with AML. I went through a lot of chemo. I had full body radiation. I was actually in ICU, I think it was for Christmas of 2010. But without Dr. Gua and his team helping me out, I wouldn't be here. I just recently got a phone call from Dr. Gua's office asking that I speak to a patient that just got diagnosed with AML. He has a 8-month-old daughter and married with a large family. I went there yesterday to try to coach them through, but you know, everybody's experience is different. And on the internet, I wish I could tell everybody prior to trying to diagnose their own problem, stay off the internet. Everything on the internet is gloom and doom, and the success stories like myself and many others in the room, you know, you don't put that out there. Everybody puts the negative parts. And it's Dr. Gua, I mean, he just kept telling me, you will make it through it. And in my own head, I had to keep saying, I'm gonna fight, I'm gonna make it. And without Dr. Gua, his team, I know Colleen was here, Francis is in the back, I couldn't have done it without them. They just kept telling me, fight, fight, and it's more in your head than it is the medicine. The medicine has changed, like Dr. Gua was saying, and it's just unbelievable the progress that they've had with cancer research. So, you know, like I said, I really wasn't planning on talking here today, but I just want to tell everybody that every experience is different for you. And your journey is going to be a little bit different than the next person. But always keep a thought in the back of your head that you will make it. You will fight to the end. So with that, I'd like to, again, thank Dr. Gua and the team here at the John Theurer Cancer Center for my success story.
Once again, thank you all for coming today. Be part of this. It's a great journey. Be involved, involve more people. It will help you, it will help them, and that's what we're here for. Thank you.
Thank you, Dr. Gua. Wonderful overview, the importance of clinical trials and participating, and for Mark for coming up. Thank you, Mark. I mean, there's nothing more than to be said for you to be here and say your journey. And again, we'll be having more of that later in the afternoon. So thank you very much, Dr. Gua. I appreciate it. And now we're going to have Stacy Weathers, the Executive Director of Leukemia Lymphoma Society, who also helps sponsor this event. We would just like to say a few words. Thank you.
So I can promise you right now I'm not going to be nearly as interesting as Dr. Gua or anyone, so let that be known. My name is Stacy Weathers. I'm the Executive Director of the Leukemia Lymphoma Society for New Jersey, and I really am just more than I can say honored to be here with all of you. I could get up here and talk to you about everything that the Leukemia Lymphoma Society is doing. We raise about $7 million here in New Jersey to support research and patient services, but it's not exactly really what I want to say to you today. I had the eye-opening experience of spending a Friday night with my almost 17-year-old daughter last night. And, you know, I asked her, I said, you know, what would you say? You know, it's not your normal presentation when you're in the room with a group of people who survived cancer. And she just said to me, Mom, why don't you just speak from your heart? Why don't you just say what you want to say? So that's what I'm going to do. She made me also watch a movie called Soul Surfer. And it was about a girl who had a shark attack. And one of the lines in the movies was her biggest competition said to her in the end, you are the definition of strong. You're the strongest person I know. And that's the way I feel about everybody here. Several years ago, I got ill, not with cancer. I am a type 1 diabetic, and I had an issue with my liver where it was storing sugar. So I wound up in the intensive care unit in a state called ketoacidosis, which is not a good state to be in, if any of you know. And I was in the ICU for about 2 weeks, and then I was moved to a regular floor. A regular floor, it certainly wasn't. It was the cancer floor. I lost most of my hair. I was pretty down in the dumps because I didn't know what was next for me. And it was patients with cancer who gave me my strength. I had been working in this field. I have been fighting for cancer patients for a long time. But the feeling that I got when I was on that floor from cancer patients who were coming around to me, who were giving me hope and strength, was amazing. You're all amazing. Today, I think you should celebrate your survivorship. I mean, survivorship, what an incredible word. And I really want to start by giving everyone here who is a survivor a huge round of applause. Really believe that. What an amazing word, survivorship. An awesome feeling, a huge accomplishment greater than none other. And a term that should last a full lifetime. And only once should you have to deal with the terms of that. It's just incredible that you can actually go through this and inspire other people. You shouldn't have to deal with this once, twice, or 3 times, and that's what many of us in this room who work on the other side, who are not necessarily cancer survivors, are fighting to do for you. I have had the pleasure of meeting a little girl who is a survivor. She's 10 years old. In her short 10 years, she has now relapsed 3 times. She's in St. Jude's Hospital, and her strength is pretty amazing. Unfortunately, she's not doing well. So tonight, in your prayers, your thoughts, if you could keep her in there. But the little girl, Maya, she keeps saying to her doctors, I want to fight. I don't want to give up. And the strength in a person going through like that, much less a 10-year-old little girl, amazes me. It's true bravery, a quality that you all possess here. Many have no clue what that bravery looks like. So LLS is fighting with you. It's, as is John Theurer Cancer Center, as with Stupid Cancer, to make sure that survivorship is, in fact, a lifelong term that you only have to earn once. We're very, very pleased to partner with both of these organizations today and hopefully provide you with education, hope, and that everlasting spirit that you have. And the last thing that I want to say is that one of the things my daughter did say to me last night when I said, how should I close the program? She told me, well, Mom, why don't you just say, if life ever gets really hard, and by the way, she thinks I'm very uncool, so she would not like me doing this at all. She made some kind of crazy hand gesture and said, you know, why don't you tell them when you get down, you got this. And I know I did that wrong, but thank you so much for being here today.
Stacy, thank you so much. And I want to put another plug in for Leukemia Lymphoma Society. I actually volunteer for them and run a support group at Gilda's Club. And when I heard Mark talk about, you know, be careful on the internet, Leukemia Lymphoma Society is a reputable organization, and you will get factual information on their website. So thank you, Stacy, for your encouraging words. Thank you.